Okay, let's take a look at some of these harder questions on complex numbers, and we're dealing specifically this time with modulus. So modulus is when you see those two straight lines like that come down like that. That's modulus in complex numbers. Now, before we start doing these questions, it might just be important to remember what modulus actually means. Okay, modulus means if you have been given a complex number, actually I won't say a plus bi, let's make up a complex number. Let's say 2 minus 3i. And I say, can you find the modulus of that? So I write those two straight lines. That means find the modulus of that. How do I do it? Well, it's very simple. I get the square root of the first number, or the real number, squared, plus second number, squared. So that is 4 plus 9, which is square root of 13. And that's it. Okay, that's all modulus is. When you see those two straight lines, it means they want you to get the square root and get the first term and square it, and the second term and square it, add them together, that's the answer. Okay, we'll come back to that as we do it. So let's take a look at this first question up here. It tells us that z is equal to 3 plus 2i. They want you to find z. Remember what the little dot means? It means multiply by z conjugate. And then hence find the modulus of that. Okay, well let's do the first bit, which is z times the conjugate of z. No need for that. Oh, it's a comma, not a 1. So, well, what's z? Z is 3 plus 2i. And the conjugate of z is, get rid of this, would be 3 minus 2i, because of course conjugates when you change the middle sign, the sign belonging to the imaginary bit. So to multiply that out, we have to break up the brackets. We have to multiply in, and in, and in, and in. And what do we get? Don't mind this question here now, I'm just going to write over this. We get 3 by 3 is 9. 3 by minus 2i is minus 6i. Plus 6i. Minus 4i squared. Okay, that's all the multiplying done for the time being. Now we always remember that I squared in complex number questions, I squared, this is always a rule, I squared is always equal to minus 1. That's a rule in complex numbers. I squared is equal to minus 1. That's always the case. So in our little sum here, we've got 9 minus 6i plus 6i minus 4, and that's actually minus 1. So we sub in minus 1 in there. And of course we have to multiply that out now as well. So there's one last little bit of multiplication to do. 9 minus 6i plus 6i minus 4 by minus 1 is plus 4. Now we've got a real, and we've got real, and we've got imaginary, and we have imaginary. So the reals with the reals. 9 plus 4 is 13. Minus 6 plus 6i. That's gone. They cancel. So it's just 13 plus 0i. So that's what z times z conjugate is equal to. Now, don't forget, hence find the modulus of z by z conjugate. Well, the modulus of this is the modulus of this. And can you remember how you do modulus? You just get the square root of the first number plus the second number. So you drop the I completely. So that's 169 plus 0, which is 169, which happens to be 13. There's the answer to that first one. Okay, now question 19. Given that Z1 is minus 2 plus I, that's what Z1 is, and Z2 is minus 3 minus 4I, evaluate or find the modulus of Z1 and the modulus of Z2. Okay, let's just write that again. What did it say Z1 is? Z1 is minus 2 plus I. Right. So what's the modulus of Z1? Well, it would be the modulus of minus 2 plus I, which is, remember, square root the first number squared plus the second number squared. Now what's the second number? Is there a number there? Yes, there is. You just can't see it. There's a 1 in there. So it's 1 squared, which is the square root of, now minus 2 squared is 4, and 1 squared is 1. So it's the square root of 5, and that's the answer. You don't simplify it to be a decimal. You just leave it like that. Okay, also in the question it tells us that Z2 is equal to, we're doing question 19 here by the way, Z2 is equal to minus 3 minus 4I. Minus 3 minus 4I. And they want us to find the modulus of Z2, which is the modulus of this. How do I do it again? Square root the first number squared plus the second number squared. Notice how I made sure to include these, because that's part of the first number and that's part of the second number. So I have to put them in. You don't just put the number in, you have to put the signs in as well. Now, when you square it, it'll go away anyway, but it's important to put it in. So what does that equal? It equals minus 3 squared is 9. Minus 4 squared is 16. So that's the square root of 25, which it happens to simplify to an easier number, 5. Okay, that's now big long question coming up. Investigate if the modulus of Z1 minus the modulus of Z2 is equal to the modulus of Z1 minus Z2. Alright, let's just write that down here. Investigate if the modulus of Z1 minus the modulus of Z2, see if that's equal to the modulus of Z1 minus Z2. Right, well, we already have this. We did it up here. It's the square root of 5. So they're asking us to see is the square root of 5 minus, now we already have this. We did it here. Remember? We got the answer is 5 is equal to, we haven't done this. We're going to have to do this. How do you do it? Well, sub in Z1. What's Z1? It's given in the question. It's minus 2 plus I. Minus 2 plus I. Minus, sub in Z2. What's Z2? Minus 3 minus 4I. Let's see if the square root of 5 minus 5 is equal to this. Right, take out the brackets. We're going to have minus 2 plus I. Now we're taking out these brackets here, but because there's a minus in front of them, it means it's going to change the signs inside those brackets. Let's tidy it up. We've got a real number here, and we have a real number here, and we have an imaginary and an imaginary here. A bit of tidying to do. we're checking to see is the square root of 5 minus 5 the same as the modulus of minus 2 plus 3 is 1 plus 5i. Now, can you remember how to do modulus? We have to do this. We actually have to do the modulus. We can now do the modulus because we have 2 terms in. You can't do it when there's big long 4 terms inside there. Can't do that. But you can do it now because it's got 2 terms in there. So how do you do it again? Square root of the first number squared plus the second number squared, which is the square root of 6. Now, is this true? Is the square root of 5 minus 5, is that equal to the square root of 6? No, it isn't. Okay? It is not equal. So when they ask us in the question to investigate if that is equal to that, our answer is not equal. Okay, you can type that into the calculator and see is it equal to that if you want, but they're not equal to each other. Okay, that's enough of that. We'll try and make another video on the last question.